Algebra I 10.1b, Simplifying Rational Expressions. Now, this is really important. If you don't remember how to factor polynomials, you're going to be lost. So please watch the factoring videos to review Chapter 6. They're going to be in the description of this video, okay? You really have to remember squaring binomials, squaring trinomials. You need to remember that, okay? And just remember factoring in general. If we have 30 over 72, if we factor the 30, we get 2 times 3 times 5. And we factor the 72, we get 2 times 2 times 2 times 3 times 3. And this 2 times 3 and this 2 times 3 can be canceled out, can't they? We can divide them out. And we'll be left with 5 over 2 times 2 times 3, which is 5/12. You remember how to do that? All right, so we can simplify rational expressions by factoring the numerator and the denominator. The common factor will simplify to a 1. We won't allow the variables to be any value that'll make the denominator a 0, so you have to really watch for this, okay? If the denominator makes it equal 0, it's undefined, all right? And we'll talk about that more in the future. A rational expression is simplified and in its simplest form when the numerator and denominator have no common factors besides 1 and a -1. So look at these two. This one is in its simplest form, and this one's not in its simplest form. Neither the 3 nor the x in this denominator is a factor of x plus 2. And in this one, it's not in its simplest form because the x plus 4 is a factor of both the numerator and denominator. We can cancel those out, couldn't we? We can just go like that and cancel them out. So simplest form means lowest form, okay? So if we're told to simplify 5x minus 10 divided by 5x, we have to factor this one out. And that could be factored to 5 times x minus 2. See? 5 times x is the 5x, and 5 times minus 2 gives us the minus 10. See? We just slide this guy over. And because these two cancel each other out, what we're left with is x minus 2 divided by x. First, we factor the numerator, then simplify by dividing out the common factor. Okay? Let's try this one. We've got 3x minus 12 divided by 5x minus 20. So we factor the 3x minus 12 to be 3 times x minus 4, and we factor the denominator as 5 times x minus 4. Now we can divide out this common factor, the x minus 4. And what we're left with is 3/5. And this expression is 3/5 for all the values of x, as long as x doesn't equal 4. Because if x did equal 4 when we plugged it in, it would make it equal 0. See? 5 times 4 is 20 minus 20. That would give us a 0, wouldn't it? Even this would be 0. 3 times 4 is 12 minus 12 would be 0. See? So as long as that doesn't equal 4, then this expression is 3/5 for all the values of x. Okay? And the fundamental property of rational expressions, it's supposed to be rational expressions there, says if we have p over q, as long as q doesn't equal 0, this is a rational expression, and k, if k represents any polynomial, as long as k doesn't equal 0, then if we have p times k over q times k, we can cancel these k's out and just have p over q. And it's based on the identity property, all right? So let's look at this one. We've got 2x squared minus 8 over 2x plus 4. First, we factor the numerator and denominator, and then we simplify it. This can be simplified to 2 times x squared minus 4, and the denominator can be factored as 2 over x plus 2. See? We can factor this as x plus 2, x minus 2, right? So we can factor that again. And we end up with an x plus 2 in the numerator and an x plus 2 in the denominator, and we can cancel those out, can't we? So all we're left with, and these cancel out, see? All we're left with is the x minus 2, see? As long as the x doesn't equal a -2, because a -2 minus 2 wouldn't work, see? If we had 2 times -2, that would be -4 plus 4. That would be a 0, wouldn't it? All right? Let's look at this one. Now we've got a trinomial on top of a trinomial. We factor it out, the numerator and the denominator, before we simplify, And this trinomial factors out to x plus 4, x minus 2. This one factors out to 2x plus 3 and x minus 2. This x minus 2 numerator and x minus 2 denominator can can divide out. So all we're left with is this numerator over this denominator, see? And as long as the x doesn't equal a negative 3/2 or a 2, because that'll make it equal 0, then we're okay, see? And remember, we can only cancel factors, not terms. If you see x plus y plus z, that is 3 different terms. But x, y, z together, that's 3 factors, and it's 1 term. So, see the difference? Okay? And remember, the denominator can't equal 0. Now, only common factors can be divided out, not common terms. And if you see 6 plus x divided by 4x, well, this one has x as a term, this one has x as a factor. So this is as simplified as it's going to get, okay? Now, in our next video, 10.1c, we're going to talk more about rational expressions. We're going to talk about what happens when factors are additive inverses, when they're opposites of each other. And if you want to see the previous video that explains exactly what a rational expression is, you can go to this description in this video and click on it to get the link, okay? And I'm going to have my playlist of factoring polynomials from chapter 6 in here. You really, really need to watch it and review it because that was chapter 6. We're now on chapter 10. That was a while ago. And any normal person is going to have trouble remembering 4 chapters ago. So don't feel bad, all right? Just watch the videos. You'll probably just watch half of each video and go, I remember. But it's going to be good for you because you really need to remember how to factor. All right? I'll see you in 10.1c after you do your little factoring review. And keep up the good work. Bye.